are different things. Child in year 5, before we get into this, in terms of the national curriculum, Key Stage 1, I'm using exactly the same bullet points here, recognising common uses of IT beyond school and knowing where to go for help and support when they've got concerns about content or contact. Key Stage 2, we have more explicit reference. So yes, understanding computer networks, including the internet, but we go further in terms of what the internet can do and how it can provide services such as the World Wide Web. We've already had examples this morning of other services you can run via the internet. Skype is a great example. BitTorrent is another example, although you might not want to talk about that in front of children. What's another one which you could use? Email. Although email is a little bit confused nowadays because typically you go onto an email website. It's a web-based access to email. But your phone connects to email without going through the web. Your phone has a direct connection to an email server via the internet. The opportunities they offer for communication and collaboration is much more into IT territory than what we're talking about. Then we also have use search technologies effectively. That's fine, that's good old-fashioned IT. But appreciate how results are selected and ranked is much more computer science content. So how does Google choose which results to show you, and how does Google choose what order to show them in? That's into computer science territory. I love this bullet point. It's the one which I often use to illustrate the difference between computer science, IT, and digital literacy. Computer science, how does Google put the results in order? Information technology, how can you find the stuff that you want? And digital literacy, being discerning and evaluating content, and start thinking a little more critically about what Google's business model is. How come they can do all of that for all of us for free? Next slide, please. So, child in year 5 comes up to you, break time, Miss, they would know the difference. What's the difference between the web and the internet? What is it you say to them? Go back to your classroom and get on with practicing for the sounds. Google it is a good answer. Find out for yourself. We want children to have that sort of inquiry-based approach to, here's an interesting question. Rather than going asking you, go and figure it out for themselves. That's a nice answer. But I've had a look on Google, but I'm still confused, Miss. So, can you help me with this? At some point you're going to give it in, aren't you?
It's the layer that sits on top.
The layer that sits on top of the internet?
The internet is a physical thing.
The internet is definitely a physical thing. We've established that much. So what's the web? Is it a physical thing?
It's the content almost.
The content.
It's
The content layer.
Yeah, so it's content, isn't it? And there's lots of other sorts of content that we can use the internet for. Anybody go any further than that?
The web travels through the internet.
Web travels through the internet? Well, you can certainly say web pages travel through the internet, can't you? Yeah? Some of the computers connected to the internet are web servers. They hold documents which we call web pages. A collection of those documents we call websites. Some of the computers connected to the internet, in fact most of them, run programs called web browsers, which lets you view those documents. And the internet is what we use to move the documents, document at a time, from a web server into the web browser. Is that a good enough thing? Would a year 5 child cope with that?
It's the bit you can see.
The web is the bit you can see, or the internet is the bit you can see?
This is the bit you can see. The web is the bit you can see.
All right.
The internet is a connection. It's an interconnection between network and computer.
Yeah, I don't like the whole network and network things Pete does.
Yeah.
I'd say that the internet is connecting computers together.
Yeah, and the web is already linked together content-wise, and then we can go and look for that all linked together entity.
I think I want to emphasise, whether it's to a year 5 child or whether it's to colleagues I don't know, that both are about connections. This is a really important and interesting idea, and both actually capture this idea of connecting together. You know, come back to what I was talking about yesterday about information. This is about connecting things together, connecting the pieces together. The internet connects computers together. The web is about connecting documents together. It's not merely documents stored on web servers. It's documents that are connected to one another, where the ideas are linked together, that makes the web what the web is. Berners-Lee talks about the history of it, which we'll get to in a few slides' time. This is Alex Kotowski. This is really good. A couple of episodes are still online. BBC Digital Revolution, Virtual Revolution. Just 1 minute of that. What's the difference between the internet and the web? Alex, tell us.
We talk about the web and the internet as if they're the same thing, but they're not. The web is simply the links, information, and web pages delivered to us over the infrastructure known as the internet. The roots of the internet can be traced back to early 1960s America, when military and university mainframe computers were hooked together via the telephone system. Email was born in 1965, and common standards began to allow files to be transferred between networks. But getting to information was still extremely difficult. Users had to know exactly where it was stored and how to tell their computer to find it in effect by phoning up another computer. The web as we experience it today, where anyone can access almost anything, just didn't exist.
Which is astonishing. Before 1989, 25th anniversary of the web, who would have got interested in the internet? Even computers in schools we had back in the 80s, but a computer on its own, what's the point? Sorry, we've heard that bit. What's the point of that? It's connecting the pieces together. You've seen the slide already, but it's worth showing it again because Norton makes the point that the web pages are one bit of the traffic that travels via the internet. It's essentially HTTP, Hypertext Transport Protocol, is a please and there you go protocol. You send a request to the file web server saying, can you send me this web page? And that's done as packets of data traveling via the internet. That web server says, there you go, and sends that web page back to you, again as packets of data traveling via the internet. The source and destination addresses will swap over. The protocol field is still HTTP, but it's a there you go bit that comes back. All of that via the internet. This is the thing I was talking about yesterday. Norton is one of these guys who thinks that the web is a passing fad and that we're going to grow out of it. But the internet won't be something which we move away from. Yes, it will get faster and faster and more things will be connected to it. But the internet is pretty much with us now. The web is just one of the apps that we run on this particular machine, this collection of machines. It's a really difficult thing to get your head around, trying to get your children to get their head around this idea that there might be something after the web. I don't know, you know. It's really hard to think of could we ever move on from this. It has become such a part. And I'd still stand by what I said yesterday. You know, just because we have the web doesn't mean to say we don't use books, we don't use writing, we don't use talk, we don't transmit DNA. You know, these things are still with us. The web is just one more way of doing this. Will there be other ways? Probably. Don't know. Who's to say?
Is there an argument that apps are replacing
I seriously hope not.
very precise?
Oh, wouldn't that be so depressing? No, the app is going back. Anybody remember Doreen Kindersley's CD-ROMs? It's an app now, isn't it? Yeah? The app, I don't know. You may be right, but I really hope not. You know, which one app do I want? I want Safari. Or the equivalent if I'm using an Android platform, I suppose. That, you know, given a choice between however much I would like to spend in the App Store or access to the web, I know which I'm going to pick.
Speaking of the common uses of
children might be on Facebook or Twitter or YouTube.
Yeah.
They all run pretty much what they're used to as apps rather
Yes.
than in a web browser in that sort of regard.
But interestingly, those are essentially dedicated, I don't know, I'm not absolutely sure, check the ideas here, but I'm fairly certain that all of that is working via HTTP GET and POST requests. It's not going to be, you know, connecting directly to Facebook's computer. It is essentially a dedicated web browser which uses the API, which runs over HTTP to say, send me this data in this particular format, and HTTP does that very, very well. Whether it's coming as HTML or not, I don't know, but I'm fairly certain it's going to be running via HTTP rather than anything more lower level than that. And some of those, that, you know, it's really very clear that this is essentially just the same as accessing it via a web browser. It's just designed to look nice and on the screen. Yeah, it's the convenience of the app is interesting. And of course, in school, it makes it a lot easier to control what you're providing access with and to target attention more carefully. But it's hard to see the apps replacing the web, never mind the internet. Please don't let that happen.
Sometimes I see the app similar to a shortcut on the
Yes.
desktop.
Oh yes, and
So
the-
CNN will send you
Yeah.
saying you would like to have a Sky app or whatever app. Actually, they have a shortcut based there to allow you to go to use the service more
And
quickly.
Touch Develop is gorgeous programming toolkit, runs on the tablet or phone-like device, but essentially the shortcut that you're installing is just a bookmark. Thing that you think is an app on the screen is just a bookmark to a web page. And web-based apps or web apps, really nice way into developing for that particular platform because you don't need to know anything more sophisticated than HTML, CSS, and maybe a bit of JavaScript. It's a nice way into getting children to create apps. But they're not apps, they're web pages, which look like apps. Okay. The early days is again interesting. So 25 years ago, Berners-Lee information management proposal. I showed you this yesterday, didn't I?
Mm-hmm.
Yeah. Okay. So you have him there working at CERN, European Centre for Nuclear Research. The heavy lifting had already been done. We had the internet. We had hypertext. What we didn't yet have was the web. So the internet connects the computers together. We've talked about that already today. The hypertext says this part, the little blue words on this document can link to another document on your computer. Think hotspots in PowerPoint presentations, or little shortcuts on smart notebook slides. Berners-Lee had the genius idea of connecting the two ideas together, of allowing hypertext to work via the internet. So I click on the blue link on one document, and that fetches another document via HTTP, via the internet, and displays that too in my web browser. This, I'm told, has now moved to the Science Museum. This is the picture on which he did it. It's a next cube, what Steve Jobs did after being sacked by Apple before returning to Apple. Not particularly successful, but interesting. Berners-Lee was using it. I'm told that it still works, but that nobody, including Berners-Lee, knows the password to it. And it's not the sort of machine you're just going to reformat the hard drive so you can get in there and use it again, I guess. But yeah, the first website created on the machine there. He tells this rather self-deprecating story about what it wasn't like, again from BBC Virtual Revolution. It's just such a nice guy. Okay, or not. Oh, the irony.
Yes, please, and the internet saying no thank you.
Yeah. Right, page refresh. What do you reckon, folks? If we lost our entire connection, that's going to be a really stupid thing to do. Present.
There's a great error message that comes up on WordPress, and sometimes we use something on it might be on one of the themes in WordPress. And if something you've not got the right connection on the page, and you want to make a message,
Yeah.
you've blown up the internet.
Excellent. Okay, well, it's not worth spending time over that. It's a nice video. You never know. It may be working if we go back to the slide deck. Talking of which, I got my photo. This hopefully is working. So CERN, where Berners-Lee was working, 93, they had the idea of, well, the heavy lifting had been done, as I say. The challenge was not so much specifying what HTML was like, what HTTP was going to be. The challenge was getting other people to use it. As with any project, having the idea, being original isn't the issue. Being creative, creating something that's of value, isn't the problem. To call it genuinely innovative, you've got to get other people to buy into it. And so the real challenge was getting other people to use the web. And I think the thing which Berners-Lee, well, CERN really, did more than any other was to make it there for free. If they hadn't given it away for free and said, look, you can do what you want with this standard, would people have still used it? Let me have a look. With a little bit of luck, we've got the live page there. Look at the web design. This is not a man who works in web design. Okay, he designed the web, but he doesn't so much work in web design. And you've got, the links. The links is the heart of the web. The links is what makes the difference. Think coming back to this idea of connections here. So what can you do? How can you help? First things first, put up some data. Make some web pages. Getting this message across to your colleagues and to your pupils that the web is what we make it. That we would have no web if it wasn't for people creating content. So put up some data. The web needs raw data, or just some views of existing databases, see examples. And even then, 93, 4 years after the original proposal, the need to write down an etiquette document of how to use this well. And it's worth looking at this. So an important aspect of information keeps us up to date is that one can trace its author. And suggesting that everything you wrote online should be signed. You should be proud of the stuff you put up there. Your name should be attached to it. You'd have far fewer problems around cyberbullying if people always owned up to who they were when they wrote something online. You know? Okay, it wouldn't go away entirely. Children will be children. But owning up to what, you know, who here is part of the TES forums? Really bitchy places? Yeah? Quite unpleasant on occasion, because people aren't their professional identity. Yeah? If you're, you know, the CAS forums occasionally gets a little bit, you know, stiff words, but people are basically polite and decent to one another because they know, you know, everybody knows who you are and where you work. And your persona as a teacher is attached to what you write on them.
It's accountability.
It is, well, accountability is part of it. It's being yourself. You know, Zuckerberg's genius with the Facebook was saying people, you know, you have one account and it's got your first name and it's got your surname on it. Okay, that's not absolutely policed. But you know, it depends on who your circle of friends are. But the fact that you have to own up to what you say on Facebook makes it sometimes a more pleasant place than other online spaces. Yeah? Okay, Zuckerberg's dog has got a Facebook page, and I don't quite know how that keeps to the rules, but Zuckerberg's dog has only got the one Facebook page, so fair enough, I suppose. The next bit does not form part of your e-safety policy. Make a page for yourself with your mail address and phone number is not something you want to be encouraging pupils to do, I would suggest. Yeah? The web was a smaller place back then. But this idea of, you know, you are who you are is, I think, something which it is worth recognising as kind of important there. I mean, there's much more content on there. It's worth going and having a browse. He also gets kind of a little bit annoyed when children write to him, and even though he's very rarely gets annoyed, children write to him and say, Mr. Berners-Lee, I need to interview you because I'm doing a school project on the internet, or some such. So he's put up the FAQ page for children, and it's brilliant stuff, it really is. So, did you invent the internet? No! What I was doing was the W3. Most of the bits I needed were already done. People had already used TCP/IP. He knows how to speak to small children, as you can tell, and DNS to make email and other cool things, so I could email other people who maybe would like to help work on making the W3. Lots of hypertext systems had already been made, which just worked on one computer, didn't link all the way across the world. I just had to take the hypertext idea and connect it to TCP and DNS, and ta-da, the World Wide Web. As simple as that. Just like that? Well, not actually, no. Actually, the inventing was easy. The amazing thing which makes it work is that so many people actually have made web servers, and that they all work the same way on the internet. They all use HTTP. The difficult bit was persuading people to join in, getting them to agree to all use the same sort of HTTP and URLs and HTML, and he's still doing that sort of thing. You know, one of the things that he cares about is the standards, is having systems which entirely do operate together. So he talks, sorry, let's just quickly check. www, World Wide Web, TCP, is an internet protocol. Or an antiseptic, thank you, I like the way you're thinking, Dawn. Transmission control protocol and internet protocol. This is how the information travels via the internet, yeah? Transmission control protocol is this thing about if the packets don't arrive, send them back. Internet protocol is the addressing and the routing of this, essentially. Yeah? Transmission control protocol. DNS, anybody? Domain name system, domain name servers, fine. What else have we got in terms of TLAs and other abbreviations? HTTP. Hypertext Transfer Protocol. URL,
Universal resource locator.
uniform, I would go for resource locator. And HTML,
Hypertext markup.
hypertext markup language. So yeah, lots and lots of abbreviations in there. Many of them end in a P because they're well, three of them end in a P because they're protocols. They're agreed ways of communicating.
URL was uniform resource locator?
Uniform resource locator. Yeah. Okay, and we're going on to URL next. Here is the URL of the website I was just showing you. You've seen these sort of things before. Let's quickly go through from either left to right or right to left. What do the different bits of the URL indicate? Files and otherwise.
The HTML at the end tells you what language the page is.
Yeah, just as on your computer in front of you there, you'll have files marked .doc and .docx or .txt for text files. We have a standard file format for these documents which make up the web. .html is the usual way of doing that. Hypertext markup language. Be quite clear, well, no, you don't need to worry about it. It ain't programming. It's coding in my view, because you're writing in a formal language that the computer can interpret, but you can't implement an algorithm in HTML on its own. But it's a way of marking up the document to say this is a heading, this is a subheading, this is a paragraph, this is a link. Yeah? Okay, so we've got the HTML bit. Which one are we going to go for next? Shall we start at the right hand end? Because that's where Chris has taken us.
Bits of directories or folders. Where
Yeah, this is the file name. Yeah, so it's file name plus extension. File is called the project. File type is HTML. Yeah, the file, if you've got index.html, that's a special file which you put in the root directory, which gets displayed. If you miss out everything after that final slash, it will look for index.html, index.php, or something like that. Sometimes you'll see index.php or the project.php. That's a page of code which creates HTML. You don't get to see the PHP, but when you call up that file, it runs a little program on the server which generates HTML for you. .asp will do the same thing. There are a number of other programs which web servers can run to create web pages. Okay, then we're into file structure, so we've got looking from the root of the web server into a folder called hypertext, into a folder called www, yeah? And then for a document called the project, type HTML. Okay, that bit's done in that case. Where do we go to from there?
That's the
main
main
address,
which is an IP address.
It's not an IP address.
No, well, not that.
Under
specific
there
address,
is
but
an
underneath
IP
there is.
Yeah,
an IP.
that will get converted to an IP address via the DNS system. What you've got there is a domain name. Strictly speaking, the domain name is cern.ch, and then we're talking about a computer registered to that domain name. Yeah. So CH is for Switzerland. CERN is obviously the organisation. The last bit there generally is the country it's based in, is registered in. So .uk, .es for Spain, .ru for Russia, watch out for those. The one country in the world which doesn't use those,
USA.
the USA. So if it's so .com is a US registered server domain. .gov would be an American registered server for a government domain. The next bit, some of them have an extra bit in between the name of the organisation and the country. We do here, for instance. So .ac.uk means it's an academic computer. .sch.uk means it's a school computer. .gov.uk obviously means it belongs to government, and so on. Or at least it's been registered as if it did. Some of those are protected. So you can't just go in and register a .ac.uk domain. Some of them are treated very, very liberally, so .org.uk, you don't have to prove that you're a charity in order to register that. It gets a little bit more complicated because we've got new top-level domains like .london and .me and things like that going in there, which you can register by just paying money across. The first bit of this bit is the computer belonging to the organisation. Normally you're seeing www there. Back in the early days, Berners-Lee and CERN wanted to call these web servers info, which would have been so much quicker to say than www, but we've generally gone with www. If you don't specify a computer name, it will go to the default one for the domain, which will typically be the web server. So most websites these days, you're not having to worry about putting the www in the front because it's a website and it will default to the web server. Okay, so that's got us as far as here. First little bit then.
It's the protocol.
Yeah. So hypertext transfer protocol is saying, is that please and there you go protocol I was describing earlier. Berners-Lee's main regret, I think, about the whole development of the web and how everything has worked is the // bit. And it says if he was doing it again now, he wouldn't have specified the / after the colon. There's no need for it, yeah? You could get by perfectly well with just http://info.cern.ch in terms of specifying the protocol. It's part of the protocol, you've got to use it. Now, it makes an interesting point that all of the typing had to do because of that. Sometimes you will see HTTPS here. What's the difference between HTTP and HTTPS? Don't say it's got an S. Secure, yeah. Remember my example earlier with all of our packets going to and fro, where Steve and Tony could read all of your messages, yeah? HTTPS is agreeing to encrypt them using a key which is exchanged just between you and the distant web server there for the rest of that communication. So in theory, the routers and the switches and all of the other computers that your packets pass through, all they will see is encrypted messages. They won't be able to see the content of your request or the content coming back with the there you go, it's an encrypted signal. That's not as straightforward anymore, and we'll return to that idea this afternoon. Yeah, Mozilla have done a huge amount about developing people's confidence in working with the web. I would really very much commend to you their web literacy standard. I think it's a failing of the national curriculum that we don't have more attention paid to the web there. Dallin said all, folks, which is going to be more useful for most of your pupils, to be able to create web pages or to be able to program Scratch. Yeah. I'm not saying Scratch is uninteresting and irrelevant, but I'm sold on the whole computational thinking idea. But actually, in terms of day in, day out using this technology, using the web or being able to create content for the web is a really important, useful, professionally relevant skill in so many spheres of life. If we were building a curriculum around what's useful as well as what's interesting, I think we ought to put more emphasis on the web as a standard, as a platform, as being able to use that confidently, competently. We've kind of taken it for granted. I'm not saying you can't teach it, far from it, but it's not the requirement that perhaps others would say that it would be. If you want to see how to put together a curriculum around developing competences for the web, the Mozilla Web Literacy Standard specification is as good a place as any. And it's nicely scaffolded, there's a clear sense of progression there. Look at the exploring strand here. Takes us from navigating, can you find a web page, through how the web works, through being able to search for stuff, through thinking about whether the content is reliable, to thinking about the security of online content, how easy it is to put up a spoof web page. Now, I'm going to come back to some of that web literacy stuff in a moment or three, but I want to go next onto search. So, firstly, is there anybody in the room who does not use Google as their search engine of choice? What do you use?
Mozilla Firefox.
No, that's not a search engine, that's a web browser. Yeah?
Okay.
So in which case you're saying I use Firefox rather than Chrome, which is fine. Respect that decision entirely. Where do you go to search for information, though? Which search engine do you use?
Okay, so I do
You do use
yeah.
Fine, okay. Everybody else using Google? And all of your pupils will use Google. If you're in a school which for one bizarre reason or another has set up Bing, you know what happens? Children go onto Bing, search for Google, and then use Google. Google is very used for this. Is that something we feel entirely comfortable and happy about?
I have to say,
But we don't do anything about it.
in my school, I've set up a homepage to be safe search at primary
Right.
ICT.
Yeah, you know where that goes? It's a front end for Google.
Yeah, I mean, an example is, it was because of a conversation I had with the ICT consultant, Brent, and because he was concerned that children using Google were getting inappropriate stuff. But And then I mentioned to him the first lesson when we were doing about Henry VIII.
Yeah.
And of course they looked up Anna Cleves, safe search. Skank came up straight away, the same search. And he said it's a great lesson to show you that you can't get perfection.
Well, you're more likely to get things which work properly on Google than you are on any other, well, almost any other system, I would suggest. Okay? It's worth, I think it is worth making the point that there are alternatives there. At least make a choice to use Google rather than everybody uses Google, therefore I've got to use Google. You don't have to use Google. There is a choice about this. I would like you to have a play with the alternative. And our friends at Bing, Microsoft, the obvious alternative, have set up this rather nice comparison site. So if you go to bingiton.com, that's bingiton, not bring it on, then you can type in 5 search queries entirely of your own choice. You will see both sets of results displayed one alongside the other. Choose between them which you prefer as your search results, and then when you get to the end of the 5 out of 5, it will say where your choices have been as you've been going through. Do you understand? Have a go at it, see how many you get. Try not to be prejudiced in that this looks like Google, therefore I like it. Okay, I just want to quickly round this session off by pointing you in the direction of some more resources. This is not enough time to get to grips with HTML and CSS. CSS is the style sheeting, the thing that deals with the formatting. As with good word processing, you start by writing the content and then later on start out the formatting. But if you want to find out more, Codecademy is a great place to start with this. It's a really interesting approach. It's all done online. So you read the instructions, do the exercise, it marks it as you go, and you get to go back and have another go if it doesn't work out properly. Thank you. The other place which is well worth looking, particularly if you want to do some of this stuff with pupils, is the decoded resources from O2 Learn. Sorry, it's O2 Learn has sponsored Decoded to produce this online version of another HTML course. This is much easier than the Codecademy materials, and it's got a voiceover commentary. With a little bit of luck, I'll be able to get the thing working. So lesson 5 is where we get to grips with making a web page, and we've got Alistair Blackmore.
Tells the browser we're using HTML. Browsers can display PDFs and other document types, so it's important to include this at the top of your page. Our first HTML element is the HTML element. Its opening tag goes at the top, with the closing tag right down at the bottom. The entire page is one big HTML element. Elements can sit inside other elements. You could put an image element inside an anchor element, for example, to make the image a clickable link. The majority of the HTML we write will be visible to the user, but sometimes we want to give instructions to the browser that the user doesn't need to see. We do this by splitting the page into a head and a body. The head is where we put meta information about our page. Meta basically means referring to itself or about itself. Inside the head tag, we have a title element which defines the title of the page. The browser uses this in the tab bar at the top of your window, and many search engines will use it in the search results. The head is also the place to include any CSS style sheets and JavaScript files. We include our CSS style sheet file with a link element. At the moment, it's an empty CSS file with no design instructions in it, so the page design hasn't changed. This link element tells the browser the location of the CSS file via the href attribute, just like the anchor element we've already seen. In a moment, try changing the CSS file name to one that contains CSS instructions and watch the page update. The body is where we put our content. Everything in the body is visible to the user. You'll recognize these elements now. Every single HTML page in the world has this structure. HTML element, head for meta information, body for content the user sees. Simple. When you've had a play with the content, let's move on to the next lesson and have a look at CSS, the language of design.
It's nicely scaffolded. How you'd use it with the class is another matter, but it's great as a resource to point some of your more independent learners to. So what do we have to do here for the tasks section? try adding one of the following CSS files to the href attribute. So it says change this so that we get the page in red, blue, or green. Let's have a look at red. And that swaps out the default style sheet, which is empty. The browser does the decision making with the other one that's given there. We can change that to one of the other suggestions. So I can go for blue, and that again swaps that out. Or we can go for green, which displays it in a different way. All of the formatting is dealt with by the style sheet. The content doesn't change. The content is dealt by the HTML. Update the content in the title tag. So my web page, my great web page, we'd change the how that's displayed in your browser. Change the content in either the H1 or the P tags. So either the heading here or the paragraph. Welcome to my great website. And we get 3 ticks in a row, and then we get on to the next lesson. You don't need to do any teaching. You just sit children in front of the machine and let them get on with it. Not sure that's always good practice. Finally, if you want to give them, or indeed you yourselves, have a chance with making websites, you don't have to do it by hand. Although doing by hand is a really well worth skill to acquire. There are some lovely tools out there. Medium is a cool new blogging platform for longer form content, and the interface is just incredibly nice. We've used Google Sites very, very effectively with all of our trainees in the past. Last year, we've moved over to giving them more of a choice. Wix and Weebly, very nice visual editors. Not a huge amount of learning how HTML works going on in either of those. WordPress, pretty much the go-to blogging platform of choice. If what you're interested in is getting children to add content to the web, then WordPress is a fab tool to use. It's not going to teach them HTML unless you make them use the text-based editor and make them write the content that way. Thimble, you've already seen. Bootstrap, brought to you by the people who make Twitter, is a framework for creating sites from scratch where the heavy lifting is just using the files that they make. But that's not something I would recommend for the faint-hearted. Code Academy have a really nice course on that now. That takes us to 1:05. I'm going to stop the recording.